Question number 31, and this question is given from first lesson, that is from real number, right? And question is, prove that root 3 is an irrational number. Okay, let's start. According to method of contrary, let's assume root 3 is a rational number. Okay, firstly we have assumed root 3 is a rational number. So we can write this root 3 in the form of p by q. Root 3 equal to, we can write in the form of p by q, where this q is not equal to 0 and p and q are co-prime numbers. Students, co-prime numbers are such pair of numbers which have only one common factor, that is 1, and factor means simply that number which divides another number or expression exactly, and there will be no remainder, right? Okay, let's take an example. Suppose here is a rational number 4 by 7, and we know that 4 is divisible by 1, 2 and 4 itself. Similarly, 7 is divisible by 1 and 7 itself. Students, here it has only one common factor, that is 1. So this number is an example of co-prime number, right? Similarly, here also p and q are example of co-prime numbers, so obviously it also has only one common factor, that is 1. Now let's do cross multiplication. p1 is p equal to root 3 into q. Now squaring both sides, p square, and this will be cancelled, so here is only 3, and q square, again okay, this is equation 1, right? And again we can write p square, and this 3 comes to this side, 3, and here q square. Now from this we can write p square is divisible by 3, so p is divisible by 3, or simply 3 is factor of p, right? According to theorem 1.3 अनुसार we can write this, right? And it means 3 is factor of p. So another factor of p is 3. Again, now from this we can write p is divided by 3. Okay, suppose 3 divides p in c times. Okay, and c is any integer. Now let's do cross multiplication. P1 is p and here is 3c. Now squaring both sides, we will get p square p and 3 square 9c square. Again, p square equal to, we have in equation 1 3q square. So we can write, instead of p square, 3q square equal to 9c square from equation 1. Right? Again, q square equal to 9c square, and here is multiplication, so 3 goes here, 3 1s are 3, 3 3s are 9. So we can write q square equal to 3c square. Again, okay, this to here we have. So we can write q square, and here is also multiplication, so 3 comes here, q square by 3 equal to c square. Now from this we can write q square is divisible by 3. So q is divisible by 3, or simply 3 is factor of q, and this is also according to theorem 1.3. So in this way, another factor of q is 3. So it has two common factor, 1 and 3. So we have to write here p and q have two common factors, that is 1 and 3, but our assumption says that p and q have only one common factor, that is 1. तर हामीले यहाँ दुईवटा कमन फ्याक्टर prime 1 and 3. So this contradiction has arisen due to our wrong assumption that root 3 is rational number. So lastly, we can conclude that over here root 3 is an irrational number. It is our answer.